Today we are going to talk about Jake Allen's 3D tube. So, who is Jake Allen? Jake Allen is a 3D artist and motion designer based in Chicago, Illinois. Recently, Swarovski Corp announced their collaboration with Jake, which is a good friend and amazingly talented motion designer. And he is now the new senior 3D designer animator for Swarovski Corporation. I'm going to have all the relevant links down in the description text. If you go to Jake's blog and scroll down past these great little things he's done, great stuff, interesting. There we go. You will find on May 18th of 2018, interesting coincidence, May 18th of 2018, this Boolean tube looping animation. It's a 10-second animation that loops around and around. And as far as I know, this is made using Houdini. And after I sat looking at it for a few minutes, I realized that it's very possible to do exactly this in Cinema 4D. And that's precisely what we're going to do today inside Cinema 4D. I'm going to show you how to analyze this scene and set it up. And for any of you non-believers out there, here it is inside Cinema 4D, where although the speed is slightly different, you can see it playing in real time in the viewport. And as you can see, it loops around every 10 seconds. And actually, it's 100% procedural. So, without further ado, let's make the wobbly wibbly sliced tube and whatnot. Anyway, we'll find a good name for it later on, although I think that Jake has nailed that. We're going to start from a blank scene. So the first thing we need to take into account is the base shape. The base shape is nothing more than a simple sine wave. So in order for me to create an animated sine wave, although there are more than one ways to go about it, I think my preferred method is the following. I'm going to create an n-sided polygon, and I'm going to set the sides to 2, and this creates a straight line, and the line is oriented on the x-axis. Fantastic. Now I want to make this oscillate as if it's a simple sine wave. I'm going to use a deformer, and particularly I'm going to use my formula deformer. Make it a child of the spline, press play, and it doesn't look how we want it to. Now, there's a very good reason for that. If you select the n-sided, you will see that the intermediate points are set to adaptive, and adaptive has the effect of subdividing splines only when there is curvature and based on this angle. So let's go to something that will force the subdivision. So I'm going to go to uniform, and you can see now that we can set this to, let's say, 50, and we have these sine waves meeting right at the middle. So let's go and fix that. I'm going to go to my side view, and if you take the formula effect and move it to one side, it'll go backwards, this side will go forwards. So I think this is the best place to put it, and I think I can set this to 200 because the size is 400, so right there in the middle. Now we still need to fix some things here. In order to be able to control the size of the sine wave and how many what the wavelength is going to be and how many bumps it's going to have and all that, we can go to the actual formula. Now what I'm going to do is set this to 1, so I'm just going to delete this multiplier. So now we are going to use the full height of the formula to control the height, and I think we can do something over here that will allow us, let's press enter, precisely to only have one wave going on at a time. Excellent. Now you can see that every 90 frames this kind of jumps, so it doesn't complete a full loop. That's because it goes only half a circle. So if I set this to 180, you will see that now every 180 frames this will loop nicely without any jumps or anything like that. So let's call this part done, because you can always go and change all sorts of things by changing your formula or the length of the n-sided and so forth. So up to this point we'll call it procedural enough to move on. Good, I can always go and hide the formula effector so it doesn't bug me too much. Now I'm going to turn my camera around so I can see this from this view. And now let's go and add some thickness. So let's go and do that. I'm going to add a circle. I'm going to add a sweep object, make the circle a child, and the other end-sided child. So there we go. I can make the circle, let's say 50, or anything else I wish. Good. So we have the main sine wave. I think it's overlapping a bit too much. Good. Now, if you want to change the shape, you can use any shape you want. You can go and modify the formula effector and so forth. Excellent. So now let's go and slice it down. Now, there are a couple of ways we can do this, but all of these ways need to use the Brograph Voronoi fracture object. I'm going to take the sweep and put it as a child of the Voronoi fracture, and you can see things are jumping around. Now, I don't want this kind of fragmentation. I want horizontal lines. So I'm going to do an experiment. I'm going to create one more end-sided, set it to 2, and I'm going to rotate this. Let me stop the animation because someone's going to get a seizure. Let me turn this upwards and 90 degrees. Excellent. And if you don't know, well, go and watch my tutorials. Go to the sources of the Voronoi fracture and delete the point generator. And instead of the point generator, drag the end-sided. Fantastic. And if I select it, I can control how many points are going to be generated. Now, we do have a few problems here. Things are kind of flicking around. And first of all, we have the colorized fragments, which I don't want. If I put on the lines, we get too many lines. Anyhow, you will see that this is kind of what we want, but not exactly. The main problem, I'm going to turn on the colorize anyway. The main problem here is that I don't have a way of being able to move these points unless I make this end-sided very long and I start animating it up and down and so forth. But I want something to work without any keyframes. So instead of using the end-sided directly inside the Voronoi fracture, I want to find an object that is going to allow me to create points on this end-sided, but at the same time can apply some animation to them. I wonder if an object like that exists. So let's go to the sources and delete the end-sided. I am going to go and create a matrix object. Set the mode to object and drag the end-sided in here. Now, if you're wondering why I didn't select linear, the reason is that without keyframes, I cannot make the matrices move. Whereas if I have an object mode in any of my Brograph objects and use a spline as the object, one of the things I can do is change the rate. So if I set this to 100 and press play, what this is going to do is every second it's going to move the first one all the way to the end. So a full cycle, if I set this to 1, will occur in 1 second. So let's go here, let's press play, and watch this go down, 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 29, 30, it pops back again. So I can control the speed by changing the rate. Now I want these to go upwards, not downwards, so I'm going to make this -10 to begin with. -10 means that every 10 seconds we're going to have this loop. So let's make this 10 seconds and see what happens. Rewind, press play, you will see that in 10 seconds this little matrix is going to go up here and then loop and go down. I'm going to just go faster. There you go. It's going to go next frame over there. Fantastic. Now I'm going to turn these on again. I may need to change the frequency of this, because otherwise it won't be able to loop. If you want to check your loops without having to play the animation, go to the last frame and go to the first frame. Well, and you can see it's the same, which means it is going to loop. Just go to 260, let it play, and there you go. So everything seems to be working fine. Let me just close this again. Now, in the Voronoi fracture now, I'm going to drag the matrix. Fantastic. And you will see that we are going to get some sort of fragmentation very soon. So the matrix Let's add 10 slices, press play, and you can see that now they're going upwards. Forget about the colors. I am going to actually select my Voronoi fracture and turn off the colors and just add a bit of a gap here. Now you will see certain weird things going on, and what we need to do, make sure you do this before you fracture any generated object. Go to the generated object, go to the caps, and make sure we have a single object created. And this will stabilize everything and avoid any holes when the fragmentation occurs. Fantastic. So we're getting our fragments going upwards. We can control the speed, but we don't have any randomization. Well, what we're going to do is use the offset and offset variation. Currently the offset is 0, so any variation won't do anything. But if I set my offset to 100%, which is the same as 0, then the offset variation is going to allow me to have variation between the positions of my matrices. Now make sure that the number you're going to use for variation is not larger than 100% divided by the count, because then you will have some matrices going above, and that will make a difference later on. So you can play up to 10% over here with 10, 5% with 20, and so forth. So what we're going to see further down the line is that we need a number which is divisible by 4, because we're going to use 4 colors. So I'm going to make these 12 and make sure that this is not larger than 100 divided by 12. So 8.3, I'm going to make it 8%. If you want to change the speed, these are going up. I thought I said 8%, but I didn't. So 8%, sometimes you need to stop the animation, otherwise it doesn't register the change. There we go. So now we have our randomization. Excellent. Now the next thing we need to do, and please refer to the little animated Boolean tube, we need to make these fragments oscillate that way and this way, that way and this way. How do we do that? Well, the Voronoi fracture, and let me hide that matrix, and let me hide the n-sided. The Voronoi fracture object, and I think I can even do this and get away with it, is a MoGraph object. And we all know that we can modify MoGraph objects in a procedural way by using effectors. Fantastic. Let's go and add a plane effector. Now we don't want things to go up, so go to the parameter, turn this off, and let's move everything towards the X. That is the type of oscillation I want to create. So let's make this 200 to begin with. But I don't want these to move all together that way. I want them to oscillate back and forth, back and forth. So what we're going to do is go to the fall-off, add a linear field, set this linear field to be on the plus y, and now you can see that we have this staggered movement towards the x. But it's very predictable. So let's go and set this to 200 first of all. How do I make these go in and out towards the x and minus x axes? Well, first of all, let's turn off the color. And the next thing is take this linear field, which you can see here it's 0, here it's 1, and let's create another sine wave. How do we do that to a linear field? Well, let's go to the remapping. This is the mapping, the current mapping. 0, 0, and 1 is 1, and the line that connects them. Go to the contour, change the contour mode to a curve. And with our spline GUI here, right-click and go to the spline presets and select a sine wave. There you go. So now we have a sine wave from here all the way to here. But it's not animating. Well, don't worry about it. You can actually change the animation speed. So here it's going to oscillate every 30 seconds or every 60 seconds if you wish to do it. So that's the other parameter you will use to change the way this oscillates. You can even make this line shorter to make the frequency higher and so forth. So for now, we're going to leave it like this. We can offset the spline if we wish to do so. You can see the oscillation happening. Again, I'll leave it up to you to change the speed and whatnot. So we've achieved the motion part. So now it's time to focus on the colorization part. And I have to admit that this was a bit tricky. Everything else pretty much came to me in real time. All I had to do was try to replicate what I was seeing with what I know that MoGraph and Cinema 4D can do. But when it comes to the colors, I had the following issues. I needed to make sure that a fragment, as it moves upwards, retains its color. And I've got too many fragments here, but don't worry about that. And that the colors repeat every 4 tiles. So it's only 4 colors over the whole of this object. So how do I do that? And yes, it took me a bit longer, a few more minutes, but I think I nailed, well, I did nail it, otherwise I wouldn't be doing a tutorial. So what am I going to do? Well, the matrix object is generating the matrices. I need a way to store a unique value for each and every one of my matrices. And the way to do that would be via the weight attribute. How do we assign weight attributes to matrices? Well, let's go first to the transform and turn on the weight. And you can see that they're all red, which means 0. If I go to my matrix weight, I can make them all 1. But this means that I have the same number, the same weight value on every one of my matrices. I want to find a way to actually make this different. So, what did I do? Well, you go to the matrix and you add a new plane effector. I'm going to call this plane weight. And in the parameters, I'm going to turn off the position and I'm going to say weight transform. So now the plane effector, that's called plane weight, is assigning this weight transform to all of my matrices. So again, I haven't solved the problem, but at least I have a proxy object that can change these numbers. Go to the for-loff of this particular effector and add a step field. The step field assigns the total values from 0 to 1, which in this case is the weights, to each and every one of my matrices. Now let me turn this off, and what you will see if I go over here is that we have these values represented by the different colors. So this is 1, and the value goes down as we go up. You can see it becomes more orangey. And as we move forward, whenever we lose, so to speak, one of our matrices, it recycles it from the bottom and continues the count from 0 to 1 and so forth. So these do not change their value as they move up. It's the new ones that are generated in every subsequent loop that get the next value. So this is just creating a total stream of matrices from 0 to 1, and it just recycles all the time. And that's fantastic, well, to begin with. And the question here is the following. How do I transfer this weighting information? And I can temporarily turn this off so it doesn't wibble, wiggle, wobble. Yeah. If we put these two words together, it's wibble, something like that. Now, I want to transfer the values we have here in the matrix, the weights, and transform them into colors. So I'm going to go back to my plane effector here, which doesn't have a color value, and I'm going to take my matrix object and drag it in here. Now, when we drag a MoGraph object in a field list, MoGraph asks us a question. Do we want that to be a point object, which means if I have a MoGraph cloner with cubes and spheres, then the points of the generated objects of the clones are going to be taken into account as the input object. But if you say MoGraph object, that serves only one purpose, to bring in the weights. So now the weights of the matrix are actually coming in here. Now I don't want them to affect our value. I only want them to affect our color. And of course you're going to say, yes, but there is no color. Of course there is no color, because in order to assign color, we need to go to the matrix field, go to remapping, enable the remapping. And after enabling the remapping, we get the color remap and enable the color remap, and let's make it a gradient. So now you can see that part of what we want to do has been satisfied, that they do have a unique color. That color is controlled by this gradient here, which of course we can change, and they hold their color. Even if I turn on this field, you will see that they still retain their color. So there's just one more thing I need to do to complete this exercise, and that is to make sure that these colors cycle every 4 and to define the colors themselves. Let's deal with the first one. Well, we can do this in a couple of places. Let's go and do it to the matrix itself. Now, remember that the plane, let me turn these off for now, spreads the values of these weights from the first one to the last one. I want this to happen every 4, let's say, matrices. And we know that we have a total of 12 matrices generated totally at any given time. So if I take this distribution and divide it by 3, 12 divided by 3 equals 4. So I want to have a situation where I have 0 to 1 for the first 4, and then 0 to 1 for the next 4, and then 0 to 1 for the last 4. So let's go to the weight, and let's go to the step effector, and let's remap this, and let's go to our curve. Let's right click on the curve and reset it so it's linear, and now I'm going to make this 300%. So we get 0 to 1, 0 to 1, 0 to 1. So let's go and see how this translates. Rewind, press play. Now you can see we have 1, 2, 3, 4 distinct colors. Or let's make it correct: white, light gray, dark gray, black, white, light gray, dark gray, black, and so forth. So the last thing we need to do, and we will call this completed, and you are going to be called wiser, is go back to the matrix, go to the color remap, and create a nice little gradient. We can start by loading a preset. I'm going to load this preset here, and we need 4 colors. Let's get rid of the whites. Let's put this here, let's put this here, and this here. So we have these 4. Let's right click and distribute knots. We have one more. Again, throw it away, distribute knots. And there you have it. We have 4 colors, which you can choose what colors these are going to be. Let's just make the matrix invisible for a second. And we have the whole setup completed. And as far as procedurality is concerned, we can go to the matrix, change the count, make sure that you change your numbers here to comply to the new numbers, make sure that you change your remapping here depending on how many colors you want to have, and so forth. And yes, I hope you feel proud of yourselves. You know now how to do fully procedural, wibbly-wobbly, tube 3D Boolean thingamadoodles in Cinema 4D. Thanks for watching.